Hi all, good evening. We welcome you to the first session on TCS CodeVita Preparation Week with FACE. We will start this session exactly at 5 p.m. in another couple of minutes. Till then, stay tuned. Fine guys, so let's get started with today's webinar. Like what most of you might have already known, this is going to be a week-long preparation webinar series from FACE Prep. So during this week, we are going to get geared up for TCS CodeVita preparation in place. So during this whole week, you're going to have webinars every day evening from 5 o'clock to 6 o'clock. And there is going to be one question, original TCS CodeVita question, which has been asked in the past years, that we will be taking and we will be learning. See, we are not just going to be solving a question. We are also going to be learning a few algorithmic techniques as well as basic approaches required when it comes to solving questions on TCS CodeVita. My name is Karthik Raja, and I've been in this field of helping students prepare for campus placements in various areas for the past 10 years. And I'm going to be handling this webinar series for you. Now, before we get into this today's class, there's something that I would want you guys to remember. See, when it comes to solving TCS CodeVita challenge questions in the first round, that's the pre-qualifier round, it's very important that you're reasonably proficient in one of the programming languages. CodeVita supports you to program in 8 different languages, but you should have proficiency in one language at least. Now, which language is completely left to you? So normally we see students the most popular ones are C, C++, Python and Java. So any of these languages that you pick up, just ensure that you develop sufficient amount of practice and confidence in these languages. Today, it does not make sense for you to learn a new language unless you're starting fresh. If you already started using a particular language, I would suggest you stick to it, because at the end of the day, there's nothing like one language is better over the other. You just need to develop expertise over it. So in case you think you need to do a little bit of learning in one particular language, there are a lot of courses that are available for free on our YouTube channel. So we have a course on C, we have a course on Python, and we also have a basic course on algorithms and data structures. So if you think you need a little bit of brushing up on these areas, feel free to go through these courses that we have on our YouTube channel. Now, before we get into today's question, let's also understand a little bit more about this pre-qualifier round. Now, this pre-qualifier round will have 6 coding questions that has to be solved in 6 hours. But you can take the 6-hour test within a given 24-hour window. So TCS is going to tell you between today evening 5 o'clock and tomorrow evening 5 o'clock you can take the test. So which 6 hours you exactly want to take it is completely left to you. Now this is a non-proctored round. So when I say non-proctored round, it means you can kind of take this test at your house, at a browsing center, at your college lab, wherever you're comfortable. So no one is going to be proctoring you, no one is going to tell you where to sit, what to do, etc. You can kind of take it at your own place. But please remember, plagiarism leads to disqualification. So whatever you do, it needs to be your own work. Like what I already said, there are 8 different languages which are supported by the CodeVita platform. Pick any one of them and build expertise in that. Now the next interesting thing is you can refer to any web source. So there's a question given, you do not know about it, etc. Feel free to Google about it. If you're lucky to get a part of the code that you need to be using in your program, you can even copy that part of the code and use it in your program. You just need to give attribution for the place that you are copying it from. So whatever is the web address that you're copying it from, that exact web address should be given in the space provided for attributions. That's a very interesting feature. Now each of these coding questions, we spoke about 6 different coding questions. Each of them will have public as well as hidden test cases. So basically whatever code that you've written, whether it's correct or not, will be checked using these test cases. Now you are considered to have completely cleared a question if you pass all the public, those are your visible test cases as well as your hidden test cases. Now whatever solutions that you give are expected to be time and space optimized. We will be discussing more about it during the course of this webinar series. And one very important thing that you need to keep in mind when you're preparing for TCS CodeVita is there is a minimal number of question repetition. That is one question. See, now this year is going to be TCS CodeVita's season 9. Now, if you were to look at between seasons, how many questions have got repeated, the number of questions that have actually got repeated in the pre-qualified round is very, very less. But there have been some repetitions, but the number is very less. As in, you should consider yourself to be extremely lucky if you get a question getting repeated. But the good news is the kind of concepts that are tested on keeps on getting repeated. You will find that in a lot of questions, just that the context is very different, but then the logic that you're using is very, very, very similar. It could be the mathematical logic that you're using, or it could be the way you put arrays to help you reduce your time complexity or whatever we are talking about. The concept repetition is very high. So when you're learning a particular question, please keep it in mind. You're not memorizing the solution to a particular question, but rather the approach of how such questions should be solved. Please keep this in mind whenever you're preparing for not just TCS CodeVita, but for any competitive coding case. Now, before I start the first question, I would want you guys to tell me, what do you think would be the cutoff for clearing CodeVita? See, last year, you might know this. People who cleared round 1, all of them got selected for round 2 and all of them got a direct interview call with TCS for their direct interviews. Now, I would want to know what you guys think would have been the number of questions that you had to clear to get a call from TCS for its interview. Can you type that in the comment section? I would want to see what is it that you guys think about it. Now, let's also keep this in mind. When I said you had a cutoff, see last year, first what they did was, people who cleared the cutoff were identified. And then a plagiarism check was done. And people who failed the plagiarism check were naturally not given the next round option. So what happened there was, there were more than 40,000 people who cleared the cutoff. 40,000. But out of that 40,000 people, close to 30,000 people failed the plagiarism check. Just about 9 to 10,000 people actually cleared round 1, that's the pre-qualifier round, and got an interview call with TCS. Just imagine this. So plagiarism check is very, very, very important. Good. I'm getting a lot of answers with people telling me any number between a lot of threes and fours. A few twos are also things that I'm seeing. But guys, the cutoff, as we officially know it, was just one question. Every student who was able to get one question correctly got a call from TCS for its direct interview. Alright, so it's not at all difficult. Out of these 6 questions, there are 2 questions which are reasonably easy, 2 questions of medium difficulty level, 2 of hard difficulty level. Even if the cutoff is to go higher this year, it's not going to go beyond 2 questions, and there are 2 easy questions to be solved. All that you need to do is identify the 2 easy questions and solve them. Good. Now let's go to today's question. We're going to be talking about the coins distribution question. This question is also known as coins required question. Now let's first go through this question and read it. Now in our webinar, I'm going to be solving this question and showing it to you how it needs to be done. Plus additionally, we are also going to be giving you access to our platform where you can go and practice solving this question. So, and this platform is very similar to the TCS CodeVita Question platform. I'm going to quickly show that to you so that you can look at the question from there. Okay, so this is the page that you will land on when you get into the, as in the link to this page is given on our, in the comment section of this, it's given in the description of this video. You can just click the description and it will take you to this page. Here we have the question that we are discussing today. TCS CodeVita 2020 coins distribution question. Now you just need to click that and it will take you to the test section. In case you are not a registered user of FacePrep platform, you will have to register for it. So once you do that, you click the take test and then the instructions are given. It's a question which has a duration of 1 hour, and let's start the test. Okay, so this is how the platform's look and feel will be, where the question is given. As is normal with most of the TCS CodeVita questions, this is a fairly lengthy question. You need to go through it, and then you have your space where you can write your program. There are different languages which are supported. Our platform supports C, C++, Java and Python. Whichever language you're comfortable with, you can code it there. Below that, there are visible test cases given. Like what I said, there are 2 cases given. And then there's a place where you can submit this code. It's going to be a little difficult to read the question on the screen. So I put the question on the presentation and I'll project that for you so that it's easier for you to read it. But before we go to the question, there's one more thing that I want to discuss about, which is the approach that you should take when it comes to solving any question. Now, when we're talking about the approach, right, I think the approach is very, very important. It's not that you look at a question and you immediately get into it and you start solving it. Step 1 is about understanding the question correctly. Because most of the TCS CodeVita questions will invariably have a twist in them. You need to understand the question correctly, spot the twist, and ensure that you're able to think of the logic. So identifying the correct logic is the next thing that you should be doing. Now, it's a very common thing, particularly in competitive coding, where 5 to 10 minutes of thinking will save you an hour of coding. Please remember this. So it's not about directly opening your coding window and starting to code. That doesn't work. So you need to identify the correct logic, think about it, then you write your pseudocode and then you start coding. Directly getting into coding will be a wrong approach. You're going to end up wasting a lot of time. So please understand this approach and ensure that this is what you are following. So first you need to understand the question. Second, identify the logic. Third, you write a pseudocode, and then finally you write the program on the platform. Now this is how we are going to structure our classes also. First, let's read the question. This is the first part of the question. I want you guys to take a minute, read it, and then I will explain it to you. I assume you would have read this page. So here we are talking about a minimum number of coins that are required to form any value between 1 and n, both the values included. Now they're also saying the cumulative value of the coins, that is value of all the coins that I have, should not exceed n. The coin denominations are given as 1 rupee coins, 2 rupee coins and 5 rupee coins. Then they are explaining it with an example of 13. So what are they saying when it's 13? Now you should be able to form all values between 1 and 13. Now they're saying the answer for this is you need a total of 6 coins. You're going to need 1 5 rupee coin. You're going to need 3 2 rupee coins. And there are going to be 2 1 rupee coins that are required. And they say this will take care of all the requirements. Now they're also telling us that you can also do this by having 2 5 rupee coins, 2 1 rupee coins and 2 2 rupee coins. But the problem here is if you take the value 2 into 5 is 10, 2 into 1 is 2 rupees plus you have 2 rupee coin. So 2 plus 2 plus 10, the total becomes 14. But clearly it is given that the total cannot exceed 13. So even though here you can do it with just 5 coins, that is 2 5 rupee coins, 2 1 rupee coin and 1 2 rupee coin, they are saying that is still not your answer because the value cannot exceed 13. Okay. There is further explanation about the question. Here they are talking about the input and the output format. So they are saying the input will be a single integer value that is given to us. And then in the output, there are 4 different items that we need to be printing. And the items that we need to be printing are first the total number of coins, second the number of 5 rupee coins, then the number of 2 rupee coins, and finally the number of 1 rupee coin. And they have also given a constraint that the value, that's the rupee value given, is between 0 and 1000. Good. So here we do not have a large value. When it becomes a large value and you're going to be running loops, that's why you need to be careful. But here we do not have that problem. Okay. Let's go to the next part of the question. So what are they saying here? They're giving us a sample input as 13 and the sample output is given as 6132. This is the same thing that was given to us in the question also, where they said for 13 rupees you can form it with 1 5 rupee coin, 3 2 rupee coins and 2 1 rupee coin. This is exactly what was given. So they're saying the minimum number of coins is 6. The number of 5 rupee coins is 1, the number of 2 rupee coins is 3 and the number of 1 rupee coin is 2. Using this you can form any value within the given value. That is, the given value is 13, so you should be able to form all values from 1 to 13. The total of these coins, if you look at it, 1 into 5 rupees is 5, 3 into 2 rupees is 6, plus 2 into 1 rupees is another 2. This total exactly adds up to 13. It does not exceed 13. Within these two constraints, the rupee value is, the number of coins is minimized. Now this is further explained in the question where they are even talking about how do you break this up. So they are saying for 1 rupee coin you use the 1 rupee. So here if you look at it now, you have 1 5 rupee coin, 3 2 rupee coins and 2 1 rupee coin. So they are saying, so with this how do you form all values up to 13 is explained here. With the 1 rupee coin you form a 1 rupee, you have a 2 rupee coin for a 2 rupee, you combine a 1 and 2 rupee coin to make it as a 3 rupee. For 4 rupees, you anyways have 3 2 rupee coins. Out of that, you can use any of your 2 rupee coins. For a 5 rupee, you have a 5 rupee coin and so on. So this is just to illustrate that all the values from 1 to 13 can be formed. Now, take a minute to breathe out because so far all that we've done is only reading the question. And the question is this long. Now, this is something that you can typically expect from a TCS CodeVita question. So reading the question, understanding it alone is going to take you a good 4 to 5 minutes and it's worth the time. So whatever we've gone through in the question, I have summarized it for you. Now what are the things? The first thing is you must be able to form all values from 1 to n. So in this case when it was given 13, I should be able to form all the values 1, 2, 3, 4, 5, 6 up to 13. Now the next thing is, the total value should not exceed n. Because in a lot of cases, there can be combinations where you just throw in a lot of 5 rupee coins, minimize 1 and 2 rupee coins. But in that approach, the total value might exceed n. This is the second constraint. See, always you need to identify the outer constraints so that you can find out solutions which do not cross your constraints or the boundary. And within that, you can optimize. So here, what are the two constraints? One, you should be able to form all values from 1 to 13. And second, the given value should not exceed the total value. That is the sum of all the coins. Whatever value of the coins I have, if I add it, it should not exceed the given number. That is 13 in this case. Now, after you do this, you should minimize the total number of coins is what is given. So it's always clear. First is you work within the constraints, and within the constraint you try to find the most optimal solution. Here we are talking about the total coins should be minimum. Now, and I'm just trying to think for a particular value, how would you minimize the number of coins? So here I have 5 rupee coins, I have 1 rupee coin, and I have 2 rupee coins. Now forget the other constraints, but let's say if I have to form 10 rupees with 1 rupee coin or 2 rupee coin or 5 rupee coin, and I need to find out the minimum number of coins. If I form 10 rupees with 1 rupee coin, then what will happen? I will need 10 coins. If I am going to form 10 rupees with only 2 rupee coins, I will need only 5 coins. But if I need to form 10 rupees with 5 rupee coins, all that I will need is just 2 coins. So if I want to minimize the number of coins, then what will happen? I should maximize the number of 5 rupee coins within the value possible. So if I maximize the number of 5 rupee coins within this value, naturally the number of coins required will come down. As we saw, to make 10 rupees, you need just 2 5 rupee coins. But then you would need 5 2 rupee coins or 10 1 rupee coins. Now after you maximize the number of 5 rupee coins, now can I say if I have a lot of 1 rupee coins, the number of coins will exceed. So what will I do? I will minimize the number of 1 rupee coins. So maximize the number of 5 rupee coins, then you minimize the number of 1 rupee coins, and finally whatever you have remaining can all be 2 rupee coins. This will be the logic towards minimizing the total number of coins that you require. Alright. Now let's try to see how do you build a logic for these questions. See, normally it's very easy to understand the logic and then solve a problem. But then if you're getting a question which you're very freshly getting exposed to, how do you solve that question? Now this is where something called as first principles of thinking comes in very handy. Not just this particular question. Any math related question can be solved using first principles of thinking. And one of the big proponents of this theory has been our Elon Musk. So what does he say about first principles of thinking? I'm just reading out his quote. Well, I do think there's a good framework for thinking. He doesn't use this for problem solving alone. He generally uses for any thinking related to life. He says what I mean by that is boil down things to their fundamental truths and reason up from there as opposed to reasoning by analogy. So don't try to compare it with something else and think. Bring it down to the most fundamental thing. That is the most elementary, most unitary thing. And from there you try to build it up. So for example, in this question, the given example was for 13. So what do we normally do? We start thinking about cases around 13. Then you start 14, you start 15, you start 12, etc. It's not going to lead you anywhere. So what would be the fundamental most starting point? The most elementary level, which is 1 rupee. Now let's say in the question, if the value was given as, n value is given as 1. That is 1 rupee. How will I do it? Now this is what fundamental thinking principle is all about. So when it comes to solving questions which are math based, I would always very strongly suggest that you use first principles of thinking, and I'm going to be using this in a few questions also. So stay with me on this. This logic helps you figure out how the logic to a question needs to be built. Alright. So here, first, if I need to form 1 rupee, that's the given value is 1. All that I can do is with a 1 rupee coin. I cannot do it with a 2 rupee coin or a 5 rupee coin. Very simply put, because that value would exceed 1. Now let's say I need to form 2 rupees. That's the next value. So this is how fundamental principles of thinking will work. You start building. From 1 you go to 2, you go to 3, you go to 4, and you keep on building till a solid logic emerges. Here what happens, if I have to form 2 rupees, I can do 2 rupees with a 1 rupee coin and a 1 rupee coin. Or I can do it with a 1 rupee coin and a 2 rupee coin. Or I can just do it with one 2 rupee coin. But what is the problem in this approach? If I try to form 2 rupees with just one 2 rupee coin, I cannot form a 1 rupee coin. So the given condition was you should be able to, so there were 2 constraints given. You should be able to form all the values up to 2. If I use a 2 rupee coin, I cannot form the value 1. Hence 2 is ruled out. What about 1 and 2? I'm again doing it with just 2 coins. But here the problem is, if I add the value of these individual coins, that is 1 rupee and 2 rupee, the total becomes 3 rupees. That was the next constraint. The total cannot exceed the given number, which is 2 rupees in this case. So both these options are ruled out. The only limited option that I have is 2 1 rupee coins. Here I can form a 1 rupee with just one of these coins. If I use both the coins, I get a 2 rupees. And the total is 2. It is not exceeding 2. So this kind of meets all my requirements. So the way I can form 2 rupees is by using 2 1 rupee coins. Now let's look at 3 rupees. So for forming 3 rupees, I can either use 3 1 rupee coins or a 1 rupee coin and a 2 rupee coin. Now both of them will satisfy the conditions where I can form all the values. If I have 3 1 rupee coins, for 1 rupee I need 1 1 rupee coin, 2 rupees I need 2 of them, 3 rupees I need 3 of them. But whereas if I use a 1 rupee coin and a 2 rupee coin, I can form 1 rupee with the 1 rupee coin, 2 rupees it's a 2 rupee coin, 3 rupees is 1 and 2 rupee coin together. I can form all the values. But between these two, we will select 1 and 2 and not 1 1 and 1, because when I select 1 1 and 1, that is 3 1 rupee coins, I would have used 3 coins. Whereas here 1 and 2 I am using only 2 coins. So after satisfying the constraints, what should I do? I should minimize the number of coins. So here the minimum number of coins would be 2. Now let's look at it for 4. Now again I have done a very similar illustration to 2, which is I can either form this with 2 2 rupee coins, or with 2 1 rupee coins and a 2 rupee coin, or with a 1 rupee, 2 rupee and a 2 rupee coin. Now here what will happen, if I use a 1 rupee, 2 rupee and a 2 rupee coin, the total in this particular case 1, 2 and 2 would have exceeded 4. The total here is 5. Here when I use 2 2 rupee coins, the problem is I cannot form 1 or 3 rupees. I can form 2 rupees and 4 rupees. So the two basic constraints are not met. So the only possibility is a 1 1 and a 2. With this I can form 1 rupee. I have a 2 rupee. 2 plus 1 is 3. 2 plus 1 plus 3. 1 is 4. I can form all the values. And this is the minimum number of coins also. I cannot further minimize the number of coins. Now, interestingly, if you have noted here, for 3 rupees, which is the value is odd, I have 1 1 rupee coin. Here for 4, when the value is even, I had 2 1 rupee coins. Naturally, because the number of 2 rupee coins that you have, the value of that will always be even, right? So 2 is an even number. So if you have 2 coins, it's 4, 3 coins, 6, 4 coins, 8 and so on. So this value will always be even. The remaining number, if you just put it as 1 rupee coins, that is the number of 1 rupee coins you require. So if the total value is even, right, I cannot have 2 2 rupee coins. I always need to keep 2 1 rupee coins. Only then the total will be even, because the sum of all the values that I get from the 2 rupee coins is always going to be even. So to make the number of, to make the total value from 1 rupee coins as even, I should always keep it as 2 coins. Please remember this. Now let's extend this logic for 5 rupee coins. So for 5 rupee coins, what will I do? Okay, now to further minimize the number of coins, the only way I can do it is I kind of try to bring in a 5 rupee coin. But can I bring in a 5 rupee coin at this stage? Definitely no. Because if I bring in a 5 rupee coin, yes, I'm minimizing it with just one 5 rupee coin. But the problem is I will not meet the other constraint, which is I should be able to form all values up to 5. If I have a 5 rupee coin, I cannot form 1, 2, 3 or 4. So for that reason, 5 rupee coin is ruled out. So what happens? The remaining value has to be only through 1 and 2 rupee coins. Like what we saw, the value is odd. So I will have 2 2 rupee coins and the remaining becomes a 1 rupee coin. So can I form all values? Yes. 1, I have a 2. 1 plus 2 is a 3. 2 plus 2 is a 4. 1 plus 2 is a 5. Good. I cannot have a 5 rupee coin. Now let's just try extending this logic to see where can I bring in a 5 rupee coin. Because that is where I will get stronger logic of, see today, now we have an understanding of where to use 1 rupee coins and where to use 2 rupee coins, and how do you optimize between 1 rupee and 2 rupee coins. We know that at any point in time you don't need more than 2 1 rupee coins. Everything else you will put it as 2 rupee coins, so that the number of coin becomes minimal. Now this is how, when you start building values from 1 to 3, that's the most fundamental values, the logic emerges. This is called fundamental principles of thinking, and you can use this in all the math related problems that come for coding, not just in TCS CodeVita but for any competitive coding exam. It just gives you a very solid way of establishing logic. Now let's try going for 6 rupees. Can I have a 5 rupee coin in 6 rupees? Now that's the first thing that we need to be figuring out for all the values that come from here on. If I keep a 5 rupee coin, the remaining has to be a 1 rupee coin because total has to be 6. So 5 plus 1 is 6. But the problem is, if I have 5 and 1, I naturally cannot form 2, 3 or 4. I can only form 1, 5 and 6. So that is ruled out. I cannot have a 5 rupee coin. So this is an even number. So I'll have to have 2 1 rupee coins and the remaining 2 would be 2 rupee coins. Now let's look at 7. Now again, here if I have a 5 rupee coin, the remaining will be only 2 rupees. Even if I have 2 1 rupee coins, with them I can form 1 rupee, 2 rupee. But I cannot form a 3, 4 or a 3 or a 4. So for that reason, again, even when I have 7 rupees, I cannot bring in a 5 rupee coin. So I will still have to, so it's an odd value, I'll have 1 1 rupee coin and the remaining 3 would be 2 rupee coins. Now 8 rupees. Here if I have a 5 rupee coin, then what will happen? The remaining money that I will have would be 3 rupees. So let's say for 3 rupees, look at this breakup that we already have here. So the remaining 3 rupees you can break it as 1 rupee and 2 rupee. So with this you can form 1 rupee, 2 rupee, 2 plus 1 is 3. And then I have a 5 rupee coin also. I can form 5. But the problem here is you will not be able to form a 4. So for that reason, even when it is 8 rupees, I still cannot have a 5 rupee coin. So 8 rupees has to be in terms of 1 and 2 rupee coins because this value is even. You will need 2 1 rupee coins. And the remaining 6 rupees will come from 3 into 2 rupee coins. Okay. Now let's look for 9. Now for 9, if I have a 5 rupee coin, how much will I have as balance? 4 rupees. Let's look at the breakup that we have for 4 rupees here. So I have 2 1 rupee coins and a 2 rupee coin. I can form a 1 rupee with this 1 rupee coin. I can form a 2 rupees with the 2 rupee coin. I have a 2 plus 1 which will give me a 3 rupees. I have a 2 plus 1 which is 4 rupees. Great. I've been able to form all values till 4, which I was so far never able to form. Now this is the breaking point because after I am able to form all values till 4, I don't have a problem further because I now have a 5 rupee coin. So what will I have? So for establishing the next value, that is 5 rupees, I use a 5 rupee coin. For a 6 rupees, again I have this 1 rupee. Combine 5 plus 1, it makes it 6. Then I have another 2 rupee coin. So 7 is 5 plus 2, 8 is 5 plus 2 plus 1, 9 is 5 plus 2 plus 1 plus 1. Precisely. So establishing this 4 rupees without the help of the remaining coins or with just 1 and 2 rupee coins is where you can start having a 5 rupee coins. At 9 rupees, I can have a 5 rupee coin because even after I have the 5 rupee coin, I have the remaining 4 rupee coins that can form all values from 1 to 4. And after that, with the help of 5, you can form all the values like what we just saw. So for 9 rupees, what will happen? First, I will have one 5 rupee coin. After I have 5 rupees, I will have remaining 4 rupees. So this remaining 4 rupees, the breakup is going to be very similar to what we saw for 4 rupees. Because only if I have it like that, I can form 1 rupee, 2 rupee, 3 rupee, 4 rupees. If I have it as 2 rupee coins, I will not be able to form 1 rupee. So I have one 5 rupee coin here, one 2 rupee and 2 1 rupee coins. So the remaining after the 5 rupee comes in is very similar to what we had for 4 rupees. Now what will happen for 10 rupees? Very simple, I have more than 4 rupees. So whatever value I have for more than 4 rupees, I can try bringing in 5 rupee coins. So from 10, if I knock off 4 rupees, the remaining value that I will have is 6. With this 6 rupees, I cannot have more than one 5 rupee coin. So I will have only one 5 rupee coin. But the remaining 6 rupees naturally will be similar to the breakup that you already have for 6 rupees here. So you're going to have 2 1 rupee coins, 2 2 rupee coins and a 5 rupee coins is what you should have here. Guys, I'm really sorry, I made a blunder here, which is from 10 when I subtract 5, it should not have been 6, it should have been 5. I'm really sorry, I missed it by oversight. So it should have been 5 here. So naturally at 10 rupees, I cannot have 2 5 rupee coins. Because if I have 2 5 rupee coins, what would have happened? The total would have been 10, but I cannot have other values other than 5 and 10. So for that reason, I cannot have 2 5 rupee coins. I can only have one 5 rupee coin. And the remaining breakup for 5 is as is given here. I'm sorry, I wrongly pointed to 6. Yeah. So this 1, 2, 2 is what will come here. Now this cycle is going to keep on getting extended. So now do we know the logic? Yes. So first is I need to keep away 4 rupees to form all values up to 5. That is 1, 2, 3 and 4. And the remaining money that I have, I will try to maximize the number of 5 rupee coins. But then I will not be able to get all the value of 5 rupee coins. Whatever I get as possible 5 rupee coins, I will keep them. And the remaining amount, I will have to split it up between 1 and 2 rupee coins. Now let's understand this better with the example that was given to us. So what happens? You maximize, I'm going to quickly summarize the logic. You maximize the number of 5 rupee coins after keeping 4 rupees aside. So why are we keeping that 4 rupees aside? Very simple. Only then you can form values of 1, 2, 3 and 4. If you don't keep this 4 rupees aside, you cannot do it. Now after keeping 4 rupees aside, whatever is the remaining value you have, within that you try to maximize the 5 rupee coins. So for us in the example, it was given as 13 rupees. So in 13 rupees, if I subtract 4 rupees, how much is the remaining money that I will have? 9 rupees. So within 9 rupees, what is the number of 5 rupee coins that I can have maximum? I cannot have 2 5 rupee coins because if I have 2 5 rupee coins, I need 10 rupees. So here I can have just 1 5 rupee coin. After I take 1 5 rupee coin, the remaining amount I have is 9 rupees. So so this remaining 9 rupees is what needs to get splitted up between the 2 rupees and the 1 rupees. So what do you do? Within the remaining amount that you have, after you have taken off all the possible 5 rupee, all the possible 4 rupee coin, all the possible 5 rupee coins, sorry, you will minimize the 1 rupee coins and leave the rest of them to be 2 rupee coins. So first thing that you're going to do is you're going to find the number of 5 rupee coins. The number of 5 rupee coins would be the maximum possible number of 5 rupee coins after setting aside 4 rupees. So you set aside 4 rupees and then the remaining amount is what is going to become your number of 5 rupee coins. Now if the number of, then after this what do? You need to find out the number of 1 rupee coins. So like what we saw in the previous slide, after you take away your 5 rupees, whatever value that you have, if it is even, then you will have even number of 1 rupee coins. That is 2 1 rupee coins. If the total value is odd number, you're going to have 1 1 rupee coin. So this is what you do after you segregate it. So after you take away the maximum 5 rupee coins, if the number of 1 rupee coins is even, that is the total value is even, the number of 1 rupee coins is 2. If the remaining value is odd, then the number of 1 rupee coins is going to be 1. Now the remaining value is all going to be 2 rupee coins. Alright. Now that we've figured out this logic, let's go on and try to write a pseudocode for this. So first what am I going to do? I'm going to get the total value as input. The next step is I need to find out the number of 5 rupee coins. So what am I going to do? I'm going to use a very simple logic. The number of 5 rupee coins will be an integral value of n minus 4. That 4 rupees is what we are setting aside for covering 1, 2, 3 and 4 rupees. After you set that 1, 2, 3 and 4 rupees aside, the remaining whatever the maximum number of 5 rupee coins will be the 5 rupee coin. So if I just declare 5 as an integer and divide this by 5, then it will give me the maximum number of 5 rupee coins. So let's say if I get it as 1.2, 1.3, 1.4 etc. because I have already declared the number of 5 rupee coins to be integer, only the integral part is going to stay. Next what do? We are going to find the number of 1 rupee coins. So number of 1 rupee coins after you remove the number of 5 rupee coins. So after you remove the number of 5 rupee coins, the value will be from the total value. You subtract the value of 5 rupee coins. The value of 5 rupee coins will be 5 into number of coins. If this balance value is going to be even, then the number of 1 rupee coin is 2. If the balance after you subtract the 5 rupee coins is going to be odd, then it will be 1. That's why we say else it is 1. Now after this what do? The remaining value will all be made up of 2 rupee coins. So from the total value, you subtract the value of 5 rupee coins and the value of 1 rupee coin. I'm sorry, it's a typo here. This should be value of 1 rupee coins The remaining will be your value of 2 rupee coins, because each coin's value is 2 rupees. This just needs to get divided by 2. That will give you the number of 2 rupee coins. The total coins will be the number of 1 rupee coin plus the number of 2 rupee coin plus the number of 5 rupee coins. Finally, you print the total number of coins, the number of 5 rupee coins, the number of 2 rupee coins and the number of 1 rupee coins as has been asked in the question. Now that we've written the pseudocode, I'm going to help you write the actual code also. See, till this point, whatever we've discussed is very language agnostic. So whatever language that you kind of code in, it really doesn't matter. Now I'm going to kind of write this code in a language that I am more comfortable with, which is Python. But then you can feel free to write it in any language of your choice. And Python is a very understandable language. So even if you don't know Python, please don't be worried. Writing a Python program is very, very similar to even writing a pseudocode. But at this point in time, if you have not learned Python, don't try to learn Python because I'm using Python here. Please use the language that you are comfortable with. With this pseudocode and the Python code that I'm going to write, you will definitely be able to write the code in the language of your comfort. Alright. So this is the question that we were seeing. We saw this in the PPT, a very long question. Now I'm going to code this in Python. So what do I do? First, I will go here, select my language. So I'm going to use Python and this is where I'm going to start writing my code. So first step, I'm going to get the input. So whatever is the value which is given there is what I'm going to get as input. Because it's going to be an integer, I'm straight away declaring that as a integer. And let's get the input. Now because you're going to pick it up from the test case and nobody is going to feeding it in, you don't need a enter your input value kind of a message here. This is fine and this will work. Now see guys, I spoke about something called as plagiarism and I see a lot of questions in the chat window coming about what is plagiarism. Plagiarism, very, very simply put, is copying. So for example, if there is a code that I use which I have copied from one of my friends or I have copied it from the internet and not given attribution, then that is considered as plagiarism. Now we've had a lot of students face this problem where he writes the code, he compiles it, he completes the entire his contest for 6 hours. He's got 3 questions, 4 questions correct with all test cases getting passed. But he has unfortunately shared his code with a few other people also and they have used it. And we've seen both the people, the person who wrote the actual code as well as the person who copied it, both of them get disqualified. So it's very important that you do not share your logic or your code with anyone. Worst cases, you definitely cannot circulate it in your WhatsApp groups or put it on a Google Doc and circulate it. We've seen people do all such kind of crazy things and we've seen everyone doing it get disqualified. Now I'm going to type the complete code. So what I'm going to do is I'm going to kind of zoom it in a little bit so that the readability is better. I hope this increases the readability. Now, so we've got the value as the input. So guys, as a part of avoiding this thing, getting caught in any plagiarism related checks, there are 2 things that I would strongly suggest that you do. One is name your variables the way you like. Don't just use single letter values to name your variables. Even for you, kind of coming back and decoding it becomes a very, very difficult task. So use good proper names. And the second is comment. So unless you're going to comment a lot, it's going to become difficult for you when you have to debug it. And this also brings in more authenticity to your code. It looks like something that you have written and you have worked on. It helps you overcome your plagiarism checks also if you're going to do a lot of commenting. So first is what are we going to do? As we saw in the pseudocode, we need to find the number of 5 rupee coins. Yes. So the number of 5 rupee coins, let's say I call this as number of 5 rupee coins, I'm calling it as 5, will be equal to, we saw that it will be number minus 4. This is to take away 4 rupees and keep it aside to cover for 1, 2, 3, 4 divided by 5. Now I want, if I directly do this in Python, Python doesn't even require me to declare the variables. It will automatically assume, because I'm dividing it as a float. But I want a integer value. So what I'm going to do is I'm going to declare this as a integer, so that the value that I get here will be a integer. Now I have found out the number of 5 rupee coins. Next, what am I going to do? I need to find, inserting a hash at the beginning will comment out the line in Python. So I need to find the number of 1 rupee coins. Now the number of 1 rupee coins will be based on the check if the balance amount. So what is the balance amount? From value, I am going to subtract the value of 5 rupee coins. Value of 5 rupee coins will be number of 5 rupee coins, which we have denoted as 5, into value of each coin is 5. Now if this value is even number, how do I check if it's even number? Modulo 2 is equal to 0. So when I divide it by 2, I get the remainder as 0. It means this value is a even number. If it is even, then we know that the number of 1 rupee coin should be equal to 2. If it is not even, naturally it will mean it is odd number. Then the number of 1 rupee coins will be equal to 1. Alright, so this gives us the number of 1 rupee coins. Next, we need to find out the number of 2 rupee coins. Now the number of 2 rupee coins, like what we saw, the value of the 2 rupee coins will be the remaining value. That is, from the total value which was given in the question, I am going to take away whatever is covered using 5 rupee coins. 5 rupee coins would be 5, that is the value of each coin, into 5 is the number of coins. And I also remove the value of 1 rupee coins, that is 1 into number of 1 rupee coins. Of course it's 1, I did not have multiplied it by 1, but yeah, it's still going to be the same. So this is the value of the 2 rupee coins. So now the number of 2 rupee coins will be this divided by 2. Now here again I want this value to be a integer. So even if I don't put an integer, it's going to be an integer value only, because the value will anyways be an even number. But I will end up getting a float value, because Python will automatically take it as float. You need to be a little bit careful. So this is where specializing in one language will make you understand the intricacies of it. Now this gives me the number of 2 rupee coins. So what do I have to do finally? Print. So I need to print. So yeah, this is where you need to go back to the question and understand what are they asking you to print. So if you look at the test cases, first you need to print the number of 5 rupee coins, then the the total number of coins, then the number of 5 rupee coins, 2 rupee coins and 1 rupee coin. So these are 2 test cases. 13, yeah, we saw this example. So if you have a doubt, you can always go back and read the question also. In the question also, in the output format, the same thing is given. So it will be, first is the total number of coins, then the number of 5 rupee coins, 2 rupee coins and 1 rupee coin. So let's just print it out. Yeah, guys, one quick this thing. Here when I've tried finding out 5, I've set number instead of value. I'm quickly changing that as value, because naturally in some cases the common ways that we kind of get the input would be number or value. I've quickly changed it as value. Yeah. So when I'm going to print it out, first I need to print the total number of coins. So total would be the number of 5 rupee coins plus the number of 2 rupee coins plus the number of 1 rupee coin, then the number of 5 rupee coins, then the number of 2 rupee coins, and finally the number of 1 rupee coin. Yes. So now I think we've done the complete code. We can do a quick run of the code and see what happens. So you run it and we get the result here. So what does the result say? All test cases are passed. Good. So the job is done. Now finally what you can do, you can also submit the code. Now see, the difference is when you run the code, only your visible test cases will be passed. If you want a custom input, you can always enable this option to give your custom inputs to check. The hidden test cases will not get checked. this box that you're able to see here was not earlier getting displayed. But when you submit the code is when it will do a check of hidden test cases also. But in this case, we've passed all the test cases and the question is done. Now guys, I want you to take a very quick look in terms of how many lines of code did we actually write? 5-7 lines. That's about it. Writing the code took us exactly 5-6 minutes. Now we were able to write the code, execute it perfectly in 5 to 6 minutes only because we got the logic correct. Now this is where I'm going back to emphasizing on what I spoke right at the beginning of the session, which is you need to follow an approach of step 1 understanding the question correctly, step 2 figuring out the logic, step 3 writing the pseudocode, and step 4 finally going to solve the question, that's writing the code. Trust me, writing the code is the easiest thing to do. That's the last thing that you should be doing. Alright guys, so before we quickly close the session, I'm reminding you, if you just watch my videos and you think you're ready to take the test, sorry, you're mistaken. You need to do this practice hands-on. That's the reason why we're giving you access to our platform for free to try out these questions. The link is put in the descriptions. That will take you to this page. You need to click on the question that we've solved today. Go there and solve it and practice it. Fine guys, so we're coming to the end of this session. So if you have any difficulties in solving this question, etc., tomorrow we will discuss them right at the start of the session. So please remember, we have this session happening for 6 days of this week. Every day evening 5 o'clock to 6 o'clock we're going to be preparing together for TCS CodeVita. And remember, all that you need to do is solve just 1 or 2 questions to crack the pre-qualifier round and get your interview call. So to ensure that you kind of remember about this, subscribe to our channel, set the reminder so that tomorrow evening at 5 o'clock you'll be reminded about this session. All the best guys, prepare well. Thank you and bye.